Hello again.
Hello again. Hi.
Hi.
Hi, Joe.
Hi.
You can hear us, right? No problems there.
Okay.
Okay.
Anyone speaking? I don't hear anything.
Hello,
Oh,
hello.
I think we're
Oh, okay.
now we are.
Wait, Christian,
I
how are
think
you
we're-
here? I thought you were at the Canopy HPC.
Nope. I had a lightning talk which was recorded, so I was there, but just virtually, I think.
Oh, I didn't know you could do that. Okay, cool. I was like, you're a clone. What's going on?
Yeah, I didn't spend the digital experience money. Oh yeah, we had the discussion. How are you? How was KubeCon?
I didn't physically go either, but I gave my talk and they had it in the keynote room, which just even watching it on camera was just like ridiculous. Like my face was like, ah, like a monster on the screen.
Cool.
Someday I'd like to go in person. It would just be so much fun.
Yeah.
Vanessa, are you at Lawrence Livermore?
I am, but I'm based in Colorado. That's another note. So this
Gotcha.
week, Christian might have mentioned this, but this week is supercomputing, which is a big conference. It's in Denver. So I think there's a lot of people that probably would like to attend this meeting, but they won't be here today because they're there.
So that's actually where I was going. I was going to ask about this because I was at Packaging Con where I actually met several of your colleagues who mentioned you in Berlin a couple weeks ago. And actually that was something when I was trying to stump up some more interest in this group, which at that point they went, oh, you know, Vanessa Sochat's actually going to be involved. Went, oh, okay.
Who did you meet? Was it Todd?
It's a small world.
Wolf?
Yeah, it was a couple people. Yeah, Todd. Trying to remember off the top of my head right now too.
Kenneth. Like I met Todd,
It was the folks
Kenneth,
working on
for dinner. That was fun. So yeah, if like next time, I think Packaging Con might be something that I should go to as well. It's in Berlin, so it's like around the corner for me.
yeah.
Nice.
Yeah, no excuse, Christian. Just like roll out of bed. Just get over there.
Yeah, kind of.
But yeah, anyway, that conflict was mentioned, so I'm not super surprised to hear that.
I guess we can wait 1 minute more and then we can start.
Cool.
Oh yeah, and it was Todd Gamblin. That's the name I was trying to remember who
Yeah,
who
that
mentioned
makes
Vanessa.
sense. Todd.
Yeah.
Did he say my last name like that? Because that's wrong.
No, nope, that's entirely my memory. So I'm
Okay,
sorry
then
for
no worries,
mangling
because
it.
it's like the worst last name.
How is it pronounced?
Socket.
Socket. Okay.
Socket. Socket.
Nice.
I never know like when to correct people, because if I don't say something, then it will like propagate and then it gets worse. But I figure it's like not such a bad faux pas to mention it so that people know. It's not like a big deal or anything.
Socket is even easier, right? I mean, it's Yeah. It's good that I have a very German name that no one pronounced correctly, so I don't even try.
Brandon, were you here all along and I just like didn't see you?
No, I just snuck in back-to-back meetings.
Ah, sneaky, sneaky.
Okay, then I guess we can start, right? So I put 2 items into our agenda for today, and the first one is discuss what participants expect from the working group. And since we launched with Joe this kick off this working group, maybe I can start and share our perspective on this, what we expect, and our angle on the subject. So basically, me and Joe are coming from the telco industry and edge devices. We are both working for Huawei, and the telco industry is moving from virtual network functions to container network functions. So they realized that we need some kind of standard way to describe containers requirements to meet acceptance like criteria when it comes to quality of service and if the container itself can run. In Europe, there is this project called Silva, which is a joint effort between telco vendors like Telefonica, Orange, Vodafone, Huawei, Ericsson, and others to run containers, this container network functions on some common shared stack or at least some unified unified stack. So to do that, we need to have some kind of standard because on such a platform you can run containers from different vendors, and the validation team often needs to have some kind of references how the container should run and what's the accepted quality of service and so on. A good example of that can be a router from 6Wind that requires a specific host requirements that the application inside can run well. So from our perspective, we are looking for some, I don't know, some standard that we can express over some maybe keywords like or subjects. This is better wording. Like we can describe kernel command lines, modules, arguments, kernel runtime configuration, and so on. That we can describe these needs. I prepared with Joe some document about that with use cases because this not only limits to edge devices or some telco specific containers, but also to different areas like high performance computing containers and so on and other stuff. So this is our expectations that we come here and set up some kind of global standard for everybody. So maybe that's our perspective. And once we move to the second topic, I will share the document and we can talk about that as well. I also know that Christian created some kind of presentation for his use cases. So maybe somebody else wants to talk about their perspective on the subject. And I just short note because I remember with Bjorn we had discussion at the beginning. We are not looking for a way to describe all container dependencies on each platform and so on. We don't want to build a rabbit hole. After studying all use cases we had and so on, for us it's just very very important to describe minimal requirements. So we are not looking for very long I don't know payload that you can describe the whole world or something like that. You will see that when we show the use cases we will present.
Yeah, I guess because I've been somewhat outspoken on this, but I've been trying to save it for this group. I guess to try to keep it brief to outline, my concern is mostly there isn't a lot of thingness. Part of the problem of why this is a problem is there isn't necessarily a lot of thingness, a lot of definiteness around a lot of the things that I think people are interested in describing. Examples of that might go from, I think that, so how do I put it? Like kernel parameters, kernel config is a very leaky abstraction. It's not, if you try to bind to it too strongly, you end up leaking the implementation of a specific kernel version and of the menu config system. For example, the hierarchy of dependent defines and whatnot. The kernel configuration is not part of the stable kernel interface and does change over time. So then you get into like the idea of like, okay, well, how does existing software handle this? We feature test system calls. So then you have to come up with naming a particular feature test, standardizing how that feature test is conducted, and then every implementation potentially has to start feature testing system calls, and you proliferate that code everywhere unless you come up with a standard library for it, and then you have language compatibility issues, like so on and so forth. So it's things like that, right? The other things I see as squirrely is that's assuming Linus. So I'm picking on the kernel right now, but like I'm picking on kernel space. Let's assume that that's Linus's tree. There are other kernel trees out there. There's Red Hat, there's Greg's LTS branches. You can't necessarily, once you can't rely on version comparisons because Red Hat kernels exist, Ubuntu kernels exist. In the HPC world, I'm sure there's even more Byzantine kernel trees that are maintained. So you can't really use version testing as a substitute. And then finally, when there's either totally alternate kernel trees, like I'm looking at, for one example, I'm used to in the end user world, we have Concalavis's widely used tree with his replacement for the CFS scheduler. That is also versioned separately and, has features that people might want to test for, like the availability of a scheduler that's not in mainline. So where do you draw the line on Linux? And like my final thing, and this is what we ended up talking about a lot at Packaging Con, and I'm actually going back and forth with Kevin Mittman from NVIDIA. And as an aside, I'm very curious if what was his name? Svonko? Yeah, the gentleman from NVIDIA who is going to be participating is going to be in the North American or the EU calls. But where I was going with that is that, even what CUDA is, CUDA versions and the compatibility between the user space CUDA components and the kernel driver and the firmware is not strictly defined by NVIDIA. It tends to be like they'll make it work when it needs to work in practice, was my conclusion from talking to Kevin at Packaging Con. So there's not a, how would I put it? There's not a hard and fast machine intuitive set of rules to define compatibility between the different components in the CUDA stack and, orchestrating those being distributed and installed by different parties and all of them working together. So defining even things like CUDA version are squirrely, I would say, without NVIDIA providing much more publicly documented guarantees about how these components interoperate than they have up to this point. That one, I think, is, maybe much more doable because we have somebody participating from NVIDIA. And if NVIDIA is committed to this effort, they can definitely make that happen, I would imagine. Not trivially, but, even things that are seemingly simple, like CUDA version, are not as well defined, right? Like PyTorch has packages based on CUDA version, but they rely on you bringing all of everything, the outer tree kernel driver, the CUDA modules and whatnot, all of them direct from NVIDIA, all of them aligned with each other. So when we're talking about containers where there's potentially some mixing and matching, some of that's allowed, some of that's not. And what versions are bundled together are not really documented anywhere except in the distribution, in the packages and installers that NVIDIA provides, what it bundles together. And there's not really a way to parse that out. And those aren't necessary. There's more flexibility permitted than, just the exact matching versions that NVIDIA bundles together in an installer. Is where I'm trying to go with that. So, I mean, those are mostly the challenges I see, is that unfortunately a lot of this stuff is really squirrely, and at least for the kernel world stuff, like feature testing has been the only sane approach in software that works really close to the kernel that I've authored that has worked in the long term.
Basically, when we were preparing some use cases, we were following guidelines from different applications that what they recommend in terms of kernel configuration and so on. I mean, I think I get your idea, but I think some part of what you described you are not able to avoid, like when it comes to expressing specific kernel configuration and so on, even if it's specific to downstream version or so. I mean, we will have to find some kind of border for all of this stuff, not to go too deep, but also we have to have a chance to describe this kind of configuration. So yeah, maybe.
Yeah, and I mean, I think that maybe it's not insurmountable, but I think that if you decide to willingly couple to some of that, you have to be very deliberate.
Yeah.
right? So like that would, for example, that would be things like fully enumerating all implied kernel options instead of the compact form that menu config makes to avoid encoding the semantics of menu config dependencies in as those change over time. So you're looking for a specific definite kernel define and not for one that implies others. It would also be things like defining that the system only works on machines that are compiled with a config because, hey, there is a kernel config to not build the config into the resulting kernel image. So you don't even know what the config of a running kernel is necessarily unless, you know, the kernel maintainer, in this case, the person who's building your kernel has opted to provide that to you.
I see Vanessa tries to say something, so please go
Yeah,
ahead.
I can't find the hand raise thing because apparently Zoom is different. I have a question. So I don't know how this is related, but one thing I've noticed is that it's becoming increasingly more common to not build. So to go back to, for example, an ML container that has a bunch of NVIDIA and CUDA stuff in it, it's increasingly more common instead of having like one huge container that has everything in it, provide pieces that you sort of put together in different ways, for efficient caching, what have you. And so if you look at those pieces, in some respect, the problem of figuring out the compatibility between the pieces would be similar to figuring out, okay, the compatibility of like the whole thing to the machine. So is that kind of compatibility in scope here? And if so, like, is that on what level should we be thinking about like the compatibility of pieces, like, because it may not be for an entire single container, it may be for containers that you bring together at runtime. Does that make sense?
I'm not sure if I understood the last part. If you could rephrase, sorry.
So if you're kind of, imagine you have like one chonker container that has everything in it that you need versus 5 containers that you're five artifacts, right, that you're putting together to assemble into the same application. At the end of the day, you get the same thing, but in some respect, if you have that single container, the person built it knowing that those things are compatible within the container, you almost get that promise, but you don't get that promise with the pieces. And so my question is, if we're moving toward a world where we increasingly have more pieces that are being brought together, assembled on demand to assemble this container, is that something that we should consider when we're thinking about compatibility? Because if we build a solution that only works for the container that we're sure works together, then it's going to be broken as soon as we move to this different model.
No, when I think about compatibility in our telco use cases, we always think about one separate container. We are not thinking about. Sorry.
And no, I just figured out how to raise the head. Sorry.
Okay.
Where is it?
Raise hand under the. It's
really
under the
quick?
reactions button at the
No,
bottom.
you can just do
They
it like
moved
this,
it.
and they recognize your head gesture. Anyhow, sorry.
Oh, if you have the computer vision stuff turned on, yeah.
I don't have that.
So continuing, when you think about applications, I mean, we thought at Telco about describing compatibility for a specific one container. If application consists of multiple containers or so, we don't think to describe compatibility. At least we didn't think of to describe compatibility for the application multiple containers, but each separate artifact, if we think about artifacts, should describe compatibility for a single container.
But maybe,
yeah.
Do you mind if I think Vanessa, you're pointing to like if you have a manifest or you have a set of layers you want to assemble for a specific container, you don't have a manifest beforehand. You just make this on the fly, basically. So the question is, if this compatibility object is only attached to a manifest list, or even a layer, right? So that you can say this layer has like binaries that are compiled for a specific CPU type. And that's maybe diving into, or not diving into, like just what I expect here is, like historically we only had the platform object, right? And we need something more to describe not only what the container is made for, like what hardware it's made for, what system it's made for, but also on the other side, like what a system administrator needs to configure on his host to run a certain set of containers, right? So nowadays it's just the site creates, and Vanessa, correct me if I'm mistaken, but the site creates it the way that they create it anyways for the native use of applications. And if it happens to work with containers, then it's fine. And if we come up with something that like not only informs the end user what container to run, but also informs the system admin what containers are out there. I think that's, for me, the goal, like to have this both ways.
So
And
I guess a couple things. Maybe there's some interesting use cases and ways of building containers, especially because I think we're talking mostly OCI containers, and in the HPC world, I'm mostly aware of the use of OCI images with what is it called? Singularity. At least with the the folks that I talk to, at least here at the University of Utah, or most of the HPC folks I rub shoulders with. So I guess I wonder if there's something really novel happening there, but I would very much like to resist the urge to describe things in terms of layers, not only because the additive and subtractive properties there are going to be very hard to capture and come up with semantics for that do what people expect in all the situations they would expect to use it, but because also fundamentally, how would I put it? If we tie something like this to layers, it will have a very bounded usefulness and lifetime. There is effort to get away from the layer model for various reasons. Brandon, do you have Alexa's blog post handy?
But I think we shouldn't and we did this in the HPC community for way too long to discuss runtimes and discuss like which runtime is best. And I think Singularity is just one that creates a snapshot that is like a singularity image format, but for distribution we need the OCI image format. I think I'm certain that this is the case, and I think most people agree on this, even though they use, and maybe Vanessa, you don't agree, but I think you agree even. But yeah, you're muted.
No, I was trying to raise my hand.
It should be under the Zoom reactions, like the little emote in the bottom bar.
Maybe then
to finish.
Just to finish this thought, I think like forget about Singularity for now. I think the idea of this object is of course to be added to a manifest. I think like that's would be my assumption. And but if we can make it so that it might be able to be even applicable for a layer as well, if that's possible and if that's useful, then that would be nice. I mean, if it looks like a platform object at the end of the day, then we can attach it to whatever we want, right? We can attach it to a manifest. We can also attach it to a layer.
Well, the thing is that layers don't have metadata, right? Like you can have a descriptor that references a layer, but the metadata, it's not self-describing like a manifest or an index.
Yeah, but
so that's the other like layer
to reference another object.
A layer is a blob of bytes.
Yeah, you can't have an annotation on the layer itself. You can have an annotation on the descriptor that points to a layer.
But then, the problem then is discoverability of that.
Yeah.
I mean, the thing is that layers are not, how would I put it? The atomic unit, the indivisible unit of OCI content, I would say is actually the manifest. The layer and the config blob are more or less the content that manifest describes, but they do not make sense standalone. The reason they exist more or less is for content addressability and attempting reuse. But for example, that's where I was trying to go earlier with like novel approaches of like combining layers in the HPC world that maybe I'm not aware of, where your containers are getting bigger. Oh, you muted yourself.
Muting myself. Sorry. Maybe I can add to that. I wasn't actually thinking of an HPC use case when I thought of this. I've been thinking about ways that people are caching in Kubernetes. So for example, there's something called StarGZ Snapshotter, and there's a couple of clones of that. And the basic idea is that you can kind of cache what is in your actual containers and then like selectively pull out different pieces as you need them. And that could have an HPC use case. So you can imagine if you need like shared libraries or something, you'd want to find those and bring them out first. But intuitively, it feels like if you're assessing compatibility and we're moving toward this world where we're interacting with individual things within the contents of a layer, not the entire image, is important for doing that. It's something that we should at least think about because we need that granularity.
So StarGZ, I wouldn't say that it quite does what you described there. I mean, essentially, it is a snapshotter that doesn't require all the content to be present to begin unpacking a useful root file system. But at least I think maybe the thing to try to agree on now, if everybody is aligned with it, is how what the divisibility of a rootfs is. Because like the idea of like combining layers or pulling pieces out, I mean, that's usually something that we would specify at build time, and then you would have a new image that would describe everything that is in that image. The idea of like, I mean, the only thing that makes sense to me there is if you're saying like you're trying to mix and match one layer with another layer across images to synthesize something new without ever having built a new manifest for that ahead of time. And I think that I mean, there is like the NixOS case, which I was exposed to at DockerCon, which is quite interesting because they have a non-overlapping content addressable file system tree from which they compose a useful cheroot, essentially. But at least in terms of Kubernetes today, and in terms of containers, the, you know, like the least divisible unit is essentially the mount namespace in the root file system. So, you know, Kubernetes, we mix multiple containers, multiple images into a sort of super container in the sense that Kubernetes pods have intersecting namespaces. So everything running in the same pod will have the same network namespace, the same PID, not the same PID namespace, the same, what else do they share? Network, IPC, there's a couple. And then things like PID namespace and mount namespace that are more key to the isolation, like each individual container having its own init PID1, each container having its own root file system. Those are still kept separate. So the compatibility but mutually between containers is typically that of the IPC or network layer, and the compatibility of your RPC service, the compatibility of POSIX IPC, shared memory, whatever your IPC model is. Christian.
Yeah, but I think for us in the HPC world, like most of our special secret sauce is handed off kernel, right? So it's like similar to the AI use case with GPUs, right? We have an accelerator card for network and for compute. Maybe we have optimized code for the CPU so that it runs as fast as possible, and that's what I think Vanessa and I care about in this regard, right? So, and I think maybe circling back to what we expect from this object, this image compatibility object is exactly that it describes what the kernel needs to have, what the user expects, or what the binaries within the container are compiled for, such things, right? And is it something that you're in the telco world, I guess, do the same, right? That maybe you have special kernel tweaks to make like networking faster. That's kind of the thing that you want to put in there.
Mostly about kernel configuration, boot arguments, like what kind of module you have to run, parameters of these modules, and so on. And we often has to be very specific about downstream kernel versions as well. So I think we cannot escape and build some kind of general specification that is, you know, we have to go into these details and the way how we thought about, because with Joe we built some kind of prototype for this compatibility, how we could discover this kind of stuff and so on, and how to validate this. So once we move on, maybe we could show it later. But yeah, you are right, Christian. That's our use case, very similar to yours, but maybe on a different level a little bit.
More on a kernel side, I think. But yes. Vanessa, sorry, you raised your hand.
Yeah, I wanted to throw in one more use case. So we mentioned Nix. SPAC is designed. So you met Todd Gamblin. Todd is the lead of SPAC, and SPAC is similar to Nix in the sense that you build one package and it has its own modular install route and unique cache. And the packages in SPAC are built for particular architectures. And so you can imagine having a SPAC, one SPAC opt package in one layer that would need to have its own kind of metadata about what is there to know if it's compatible. So that's another HPC use case that is similar to Nix, but not Nix.
Muted myself. So that's what I was gonna get at. What I was gonna ask about actually, because I think the like layers and rootfs composition thing is more of just an aside that I'm not sure really has anything, any substance to it if you really dig into it. But I think the most interesting thing to me, outside of the like technical question of like how do you implement, what do you define, where do you draw the line, what's the definiteness of something you're trying to describe, is how do you expect to action on this information? And there's everything from, is this just like a throws up a compatibility warning, but there's no change in semantics for the ecosystem? Or for example, and this is I think what probably applies to the HPC use case, are we introducing more granular platform selection at the runtime level with potentially a fallback to the most generic version? So say that I have a AMD x86 or an AMD 64, x86 64 V3, what do they call it? Architecture version? I forget what Intel called this, but sub-architecture. Say that I have a sub-architecture version, and then I have a more specific sub-architecture version with some specific out-of-tree kernel module. And then I have a version of the image that is just generic x86 64, works on any kernel, works on any, AMD 64 machine, any microarchitecture or sub-architecture, but, suffers performance. And then we expect the runtime to pick the one that is most suitable for the hardware, or potentially are we doing something like this image requires this kernel module will not run without it. So when I am scheduling this on a Kubernetes cluster, I expect the Kubernetes scheduler, the control plane, to be aware of the features of certain nodes and to schedule this pod onto a worker with the appropriate features to run it. Like there's many different places in the container stack where you could action on this information. And I would say today, especially before we even get into defining anything new, the state of Kubernetes scheduling around container images is pretty dire in that, Kubernetes has basically delegated the all scheduling of the actual content that runs to the runtime, which has mostly worked up until this point because all people has cared about is platform. But for example, I cannot schedule a foreign architecture image on a Kubernetes cluster. If the kubelet says I'm AMD 64 and I run a if the runtime says I'm AMD 64 and I run a multi-platform image there's no way for me to actually say, no, actually use the ARM 64 version, for whatever reason. I don't know why you would do that yet, but it's definitely a bit of a hole that CRI cannot express any sort of scheduling hint to the runtime layer.
But I think the we have different layers we are talking about, of course, right? We have the decision at runtime what image to pull or what image to run. We have the distribution part where we want to display this to the end user to discover the best image for the application that the user wants on the registry level. So we need the information there as well. And of course, we also need it for the scheduler eventually. But I think what we need for the first is like perhaps this information anywhere that we can agree on, right? I mean, if it's we in the HPC community, we kind of fancy the annotation for now because it's the easiest way to describe this, right? So we will have, ideally, we would like to have like a org HPC CPU architecture annotation for a manifest so that you can say like, this is the image or the image is built for this. But we need this information, and then we can discuss like how different parts of the ecosystem use this information. So I think like I don't think we need to discuss every aspect and every layer that will use this annotation or this information. Sorry, but I think at the end we first need to start somewhere and have this information somewhere, right? So and then people can pick it up or leave it. And you are right. I mean, there is a decision where the spec guys put a lot of time in to make sure that they have a solver to get the best image for the underlying system, and this kind of like, that's of course like super complex stuff, but we can hopefully reuse this logic within the container as well and empower the scheduler to pick the best image from the ones that are presented with this object that we are going to define hopefully.
So I do think how we want to use this really defines what options we have to pick and use. And so if we were to say this was something we were only going to use on the scheduling side, and we had a single image, we want to figure out what nodes we could schedule it on. I know there's been a push to look at like the artifact process to attach some kind of external metadata to it. If we were to do this at a runtime level, though, I think that gets pulled out as an option. If the runtime is looking at this, it's going to be looking at the index and it's got to look through a dozen different entries in that index, has to find the one that it can run or the one that it wants to run the best. And so at that point, you're looking at either a platform entry or an annotation. So I think it's important to make sure if that is a use case we want to have, that we know that we're constrained to those areas that we're looking at, something in the descriptor itself.
And real quick, just to add on to Brandon's answer there, like the current semantics we have are basically you take the first thing that looks like a likely match, but even that is kind of a loose consensus, I would say. Like at the runtime level, we currently don't strongly assert that we have standardized how we do selection from an index, nor have we abdicated that and said this is completely implementation defined. So the status quo today with Kubernetes works because Containerd and Cryo implement I take the first likely match. And there's degrees of compatibility even. There is a complex comparison logic that actually exists there because, for example, I could run 32-bit ARM on a lot of 64-bit ARM CPUs, but I should prefer the ARM64 image even if it didn't come first. So there is actually like a two-step, at least in Containerd, platform selection and sort function there that it uses, where basically it takes what is ranked as the most compatible first, the most best for the current platform. But like all of those things, like, yeah, to what Christian's saying, I don't think we have to enumerate the whole world, but certainly knowing what the use cases are means that you know where you're going to have to convince people to adopt this.
Yeah, so maybe a few words from Telco and me and Joe about that. Joe, correct me if I'm wrong, but from our own perspective, we thought about this compatibility artifact not being involved at all. I mean, the scheduling part and all the way how it works right now should stay as it is. And we thought about compatibility artifact as some addition when it comes to validating node, but without not on the runtime level. The runtime doesn't need to know about this artifact at all. We thought about defining some kind of standard that is helper to run containers, but it should not be involved in the runtime itself. If it makes sense what I say right now, if you get my idea, it's just we keep still the fields, platform OS, and architecture and so on, and the decision which container should be pulled is okay. It's staying the same as it is, but over the artifact we point to specific image manifests, and based on that, which container has been pulled or whatever, or on our tool try to predict which will be pulled. We get appropriate artifact and read if it's compatible or not on the host. I mean, it can be fine-tuned how it works, how it should work, but we didn't want to involve the artifact itself into runtime.
Some comment, additional comment. For the compatibility, it's not only just for scheduling and how to run the container on the host, but also for the cluster manager, how to prepare the cluster, how to configure the cluster node, and how to reconfigure the cluster node or scaling the cluster. Even for upgrading, or scaling the cluster, you have to use the compatibility information to make sure the cluster can meet the demand of the container. And so for maybe it's a little early to discuss how to implement the compatibility. Maybe we need to discuss first for the use cases and the scenario we want to adjust.
Yeah, so I'll jump in. I don't know if it's been explicitly stated, but on the original working group kind of issue where we had this discussion, there's a lot of discussion about like, are we adding something to an existing spec or are we making a new spec? And that kind of goes back and forth between like, okay, are we trying to figure out like what those features are, which is like almost an impossible thing, or are we trying to figure out some way to empower people to customize some kind of new spec to work for whatever their use case is? So that last statement that you made about kind of starting with the use cases, I think that makes a lot of sense. But I do think that trying to start with like, let's figure out like the features that we want is, in my mind, the wrong approach. My gut is saying to kind of build a spec that is very generic, like a skeleton for something that could be implemented actually in different contexts, because we're going to need it in different contexts in the Kubernetes scheduler and runtime cases. And I don't think we can develop something toward like one specific use case, but maybe we can make something generic that we create this initial skeleton design. we hand it off to people, so to developers, and we say like, okay, given this spec, this skeleton, and your specific use case, and maybe it's a very niche use case and no one else is going to have it, no one else is going to care, but like if we do it generic enough, then maybe it'll work for you. Like, so to step back, I actually think we should start thinking about the use cases with the implementations, and then something generic that could be used in those different places, and then let people play with that and explore it, and then move in the direction based on feedback from that.
Yeah, sorry, go ahead, Christian.
Yeah, I'm totally like doubling what Vanessa said. I think, as I said, our idea initially was to create annotations that describe the image and describe what the image expects from the host. So maybe that's a stepping stone towards something that is an object that we might want or want not to create, right? I mean, if we agree on a format, on a notation for those kind of information, like from the HPC world and maybe from others as well, and we can maybe refine this kind of annotations, and if we figure at the end that those annotations are so heavily used that it's worth putting them into another object or extend the platform object or whatever. I think that's a flexible way to create this, because we can annotate manifest lists, we can annotate a lot of things, right?
I think you can go ahead, Bjorn.
Yeah,
Okay,
you're the only
it
one
looks
with
like
your
everybody
hand
put their hand
up.
Yeah, so I think this maybe dovetails with what I've been discussing with the WASM folks, because recently there's a colleague of mine is one of the maintainers of Run WASI, Yuki, a couple of things in the WASM ecosystem, and I recently got roped in as the resident person with OCI opinions to help them with some of their ideation. Here's my take is, I think what makes the most sense, especially if we don't want to say these are the definite use cases now and start trying to move the whole world, right? Because the thing is, like, if we don't, how would I put it? You need some form of standardization, semantics for people, because the problem is going to be then if I'm just going to pick on Kubernetes here, but this goes for other areas of the container ecosystem. If we don't standardize, what the platform semantics, selection semantics look for, like, here's how we detect x86, 64, v4. And here's how we decide that, this is the best image to use and how we do platform selection. You're gonna have the situation where, like, hey, my thing runs faster under containerd than under cryo. What gives? Oh, Red Hat implemented the logic slightly different, and now it's finger pointing who got it right and what's the reasonable thing to do and how should we order the things in the manifest to try to get containerd and cryo to both behave the same because their logic is different. So we have to fiddle with the order of data and whatnot. I'd rather try to avoid that world. But the flip side of that is that, like, if we're allergic to the idea of, like, these are the definite use cases, these are what is supported, and defining that strictly, maybe the thing that makes the most sense is what I've suggested to the WebAssembly folks, which is completely independently from anything else, start defining definite things. This is something that you can reason about. This is something that has definite semantics, like CUDA, like a kernel config, like a kernel module, whatever you decide makes sense. And, then we can argue about, can you actually detect this, yada, yada, yada. Is this a safe thing to try to encode? And then come up with at least some guidelines how people might start taking advantage of that information at different layers. But first define what you're able to detect, different ways you could encode it, and then worry about things like selecting the right image, scheduling it onto the right worker, integrating with NRI and CDI in the Kubernetes world to say this needs an NVIDIA GPU of at least the Ampere generation, schedule it onto such a machine, and then use CDI and NRI and interoperate with those to make it, to actually schedule that and wire it up to, NRI for discovery, CDI for communication.
This might be overly simplistic, but the way that I've been kind of thinking about it is, imagine that you had almost like a compatibility package manager. And then, for example, just like in Go, you had GitHub URIs where different vendors, different OSs, whatever, they maintained recipes that said, like, okay, here's the most up-to-date thing for how to check that your container is compatible with our thing. And then that means that you would just put the reference for some particular version, you know, on GitHub of this compatibility thing. And it would be, and so then the burden of kind of maintaining that would be, you know, scoped to the people that maintain it. And then the spec that we design would just be kind of the orchestration of how to define those things and then how they actually get to run.
I would like to stress another angle that we should take into account, because I think maybe this is the 90% use case for this anyways, is this discoverability of containers, right? And like, if folks look for the latest PyTorch container for their environment, what do, right? They run it, they download it from NVIDIA Cloud and hope for the best. If we can provide them this information coupled within the container to discover the best container for their actual setup, that would be great, right? So that a registry can say, like, you are on a HPE whatever system with this operating system. If we can create it so that they can reuse this information to discover containers, I think that would be great. And then the rest will follow. And then, as we said, like, if the sysadmin then knows, okay, those are the range of containers that I expect to run, we can maybe create those container setups and react to the annotations or react to the object at runtime, something that the Ceros runtime already does, right? It looks at the annotation and then it triggers OCI hooks. So I think that's kind of what I think is a good way forward. Discoverability.
Yeah, so I will just continue. Yeah, so our telco use case is a little bit different because we wanted to leave I cannot pronounce that word, discoverability. We just didn't want to mess with that, to be honest. We just wanted to leave it as this. And based on that, we just wanted to find out about artifact that describes compatibility for this container. And our idea, I think, is the closest to this what Bjorn said about defining some kind of fields, subjects, or whatever, like kernel configuration, boot arguments, modules, and figure out how to check those kind of stuff. And I as I told you, with Joe, we came up with this document I just shared on the chat. And in the summary, I hope I sent appropriate section. If you scroll down, there you have a summary on the left side. And there you have some kind of stuff, some kind of subjects that we wanted to validate against. The yellow one is marked as stuff that has to be discussed. And we also came up with some very simple, this is just a prototype, how to discover this kind of stuff, right? You just, for example, for kernel configuration, you go into boot directory, you check what is in the compatibility, what kind of configurations are set in there, and you validate if the operating system has this or not. We just wanted to have something very simple to validate that, and we didn't think of changing the way how containers are being discovered. And we wanted to make this image compatibility optional. We didn't want to change, force users to write those kind of stuff, and it would be up to them. If they want to have this, fine. If not, then just try your best and see if your container will run as you want. We wanted to have something kind of optional under OCI that defines a standard. You know, that's our perspective on that.
But I think the information needs to be sourced from somewhere as well, right?
Yeah, I mean, there is some kind of mechanism today, like which speaking the appropriate container. Maybe the tool which is reading the artifact could replicate the mechanism and pick appropriate one or something similar. Maybe we didn't think this through very carefully, but
I mean, ideally, and maybe just one sentence, Brandon. I think ideally in HPC we always say, like, let Todd do it for us. So if, like, the guys who build the container with Spec or EasyBuild or whatever, if they create those information and bake it into the container, then it will be perfect, right? Because it will be automatic and we don't need to care about it. I think that's our goal, I think. But yeah, sorry, Brandon.
So Marcin, do I understand you're pushing to have this as an external artifact?
Yes, just an external artifact.
So in that case, how do you envision someone would be accessing it, discovering it, consuming that content?
Well, because usually I can imagine that because we have specific use case, we have a validation center under Silva, for instance. So before sysadmin is deploying the container, it kind of knows where it will deploy, what kind of architecture, what kind of CPU, and so on. And they can get this information ahead from the container itself. Like they think more or less they will know what they will run there, so they could pull artifact ahead and check this information.
Yeah, like
Because-
Yeah.
I'm thinking a lot of other people here might be thinking along the inverse use case, where instead of looking through a list of container images and looking at each one, seeing does this have my artifact on it, does this one have it, shifting that to be something that's pushed down to the runtime of, here's your one index of all the different container images that implement this version of whatever, and run the most appropriate one rather than make that a manual task, make that something that's automated within the computing itself of the runtime.
yeah, I understand.
Yeah, because Marcin, it sounds like what you're describing is, keeping today out of band, so say there's, again, I'm going to pick on CUDA now. There's like 15 different CUDA images on Docker Hub, all a different CUDA version. And that is encoded into the tag, not into the platform, because we don't have any semantics for encoding CUDA into the platform. So you pick the right tag with the CUDA version, and it's got your multiple architectures in it, and then you build derived multi-platform images from it. And then as the sysadmin, I'm going to go like set up a manual Kubernetes scheduling constraint to make sure that the right CUDA version lands on the right nodes with the right hardware. And I'm doing that all out of band. And so, I think what you're describing is, not solving that part of the problem. What you're more interested in seems to be more like the script I linked. This is what we use for upstream Moby. This is a, very heuristic, like it's not hard and fast, but the idea is that this is a shell script, which just says, does your kernel look like a sane place to run containers? Do you have all of the kernel config options that we expect?
Yeah.
With again, there's a huge asterisk on that because of the concerns with, kernel config being an implementation detail, the build system, like I mentioned. And it also, does things like, we check syscontrols, we check, just things that are known to be, we check a couple kernel command line options, things that are known to be problematic, potentially insecure, or just a complete showstopper. And essentially, it seems to be like, like what you're describing is like, what if we built a generic version of this that just like this script, we have check flags, we have check command line, we have these different ways of expressing, here's a thing the script should validate. And then what if we essentially standardized what check this kernel config means, and then we baked that information on what to check into the image? Only, in your case, like not necessarily into the image itself, like a descriptor, like Brandon and I are talking about, but instead as an artifact.
Yes. This is kind of our use case here, right? We were coming from this angle. Maybe it's not completely valid, but this is what we wanted to have, some simple check over specific subjects and tell if this container can run in there. And maybe in the future, there will be a good way of, I don't know, influencing scheduling decisions or so. But we didn't think very hard about how the discovery should happen, to be honest. So, yeah.
Yeah, I wanted to just quickly say +1 to the artifact idea, like kind of to discover things like the other direction that we've been talking about. And it also kind of brings up something I was thinking about in terms of, and this was also in the discussion in the working group issue, just about what our vision is for, granted that we make a thing. So let's say we design some kind of, spec that describes for an artifact. What is our vision for how developers of different tools that, for example, HPC centers, Kubernetes, whatever, will actually take advantage of to interact with that? Is our expectation that, the most common tools are going to be adding, new commands to interact with this thing? Are there going to be new tools that are created? It's going to be new tools or part of existing tools? Like, do we have vision for that, or do we need to have vision for that?
Yeah, I think we need to have this vision, and I think we already have those kind of tools like RSpec, for instance, right? I think, and the artifact, still, I think we can start with an annotation, key value pairs that describe all of that, and then we can bundle this into an artifact if we want. And we have the same problem, like you said, right, Marcin? If we download 50 gigabyte of a container, and then just to discover that the binary is not built for the specific CPU and it will segfault. So I think this kind of little smoke test tool that reads the annotation or the information, whatever the information is stored in, but for me, it's annotations first. So if we have a little tool that checks, okay, give me the annotations of the container and I will check if it will actually work on my host. I think that's kind of what our idea was in the HPC container conformance project. So that we have this smoke test to not download 50 gigabytes of image before we know it. And then also to, as I said, make it part of the registry information so that you can filter for a specific specific annotation in my case. And also like have tools that runtimes and schedulers can hook into. But that's of course down the line. I think first we need those information in some shape or form. And our initial idea was use annotations and then see what comes out of it. Yeah.
I'll give you a parting thoughts. We're running up to the end of the hour here, which is that you can always add more fields in OCI. Whatever you have this JSON, you can add additional fields into there and additional structure into that. So the platform object is not fixed. We can add more stuff into the platform if that makes sense for what we're trying to do. And so if we're...
And platform is even like a pseudo open, like it's a extended descriptor, I think is what we called it in the spec. So like it is defined in the spec, but platform is not even optional. It is like sort of an addendum. Like, you know, what I'm trying to say here is like you can find your own thing that's not platform and it's every bit as legitimate as platform. Platform is sort of an extension to the descriptor as it is.
But yeah, how, like, what is the benefit of the platform object if we can now annotate manifest lists as well, right? So we don't need the platform object anymore if everyone has an annotation.
Well, you don't have to. You don't have, I mean, annotations and platform are just ways of adding JSON keys. Annotations is just a little more structured and a little more plumbed through an existing tooling.
So I would say annotations is less structured. Annotations is a free-form key value store where we can put some structured content into the platform if we decide that we need that structure.
So,
yeah, and I think that would be a good, sorry, Marcin,
that's
sorry,
okay.
Go ahead.
My problem with, with platform and annotation is that what if requirements change over time, even it can be a short time, then you have to release a new image, right? Like new version of the image.
You would have to push a new index, which is a single manifest, however many kilobytes that is, assuming it's more than a kilobyte.
Okay.
And you can do this in the registry as well, right? I mean, it's not the client that needs to push it. You can, and
anything that has push access to the registry. So whether it's a process on the registry or some client processes doing those checks.
Or the registry can also be smart and maybe find the best image for you and just push it. But yeah, that's
so
not
so
really
the registry won't be able to tell you to the client, here's what you need to pull because it's got a whole list. It doesn't have all the details the client has on its local machine. Also be very careful. People get very sensitive when registries change content. When there's a content addressable store, people get very addicted to that digest. And so if it's going to be changed, somebody typically outside the registry is the one that's pushing, here's a new index with a new digest that has the new list of platforms we support.
Yeah, I like Fire.
But I guess also that is kind of my last takeaway is that remember that the content, the underlying content, the rootfs is content addressable, you know, with its imperfect reuse. Like if you construct your layers well, it does cache well, you know, caveat author here. But I wouldn't be afraid of pushing new manifests. I understand that like one of the reasons for the idea of using artifacts as the primary or exclusive vehicle for delivering some of this information is that it allows for mutability later. But the flip side of that for me would be that the just because the manifest changed doesn't mean that you have to get the config or the layers again. It's literally just the JSON that encodes some of this information, like the compatibility changed. And so I think it makes sense probably to support both. Probably, like it, especially depending on the use case, like for the HPC use case, if I want to select the compiled for my native CPU with all the bells and whistles in the compiler, I think that we really would benefit from having that information in in the index and not having to fetch another index, just several layers of index. We have to get the referrers, and then we have to get all of the indexes there, and then we have to do a comparison, find the, okay, does this one say it's compatible? Okay, I think this is right. Like, it's much more straightforward if we don't have to implement that kind of logic. Like for Marston's use case of like a after the fact, post facto sanity check, I think it makes a lot of sense. But then in the case of like a runtime where I want to pull and run the content as fast and as efficiently as possible, and I want to pick the thing that is most optimal, my point that I'm trying to say is I think there's room for both. And I really would try to avoid being afraid of the image changing, because as long as the root hasn't changed, it's not like you're getting that 50 gigabytes of data that's in there for some reason again. All it is a new JSON blob, and it's much more efficient in terms of round trips and the complexity of implementation and getting it correct if we can label the package instead of having to peek inside the box to figure out, is this appropriate for me or not?
Yeah, how about we use next week's European meeting to just maybe put our ideas of annotations or information next to each other and see if we find some similarities.
I thought maybe, what do you think about doing this over mailing list, that we could start a thread and try to collect some subjects we share? That would be the best, because I'm not sure, to be honest, about EU meeting next week.
Okay.
Today it was kind of demotivating, but let's see.
It was 3 people. It was a trio already. So
yes.
I think all three
it
are
would be great
here
if
in
we
this meeting
can,
too.
if we can figure out the best way to work together that doesn't sort of predominantly choose one time zone. So a lot of asynchronous documents, and then people can show up to the meetings to discuss. And
if they also don't miss it like I did.
I was about to say, I saw you joining in right now. I'm worried that you had the time zone off on your calendar. So we're just wrapping up.
No, I literally
just
just looked in and was like, oh, there are still people typing in the document that I missed. I should maybe join in.
welcome and goodbye. No, I'm just kidding.
Yeah, I got to drop. So thanks, guys.
Thanks, everyone. This was really
Dale's here.
fun.
Everybody run.
We'll hopefully have more
Okay.
HPC folks after SE. So
Thank
goodbye.
you. Bye-bye.
So long.
Bye-bye.
Farewell.
Thanks all.